Hello friend, myself Sanjeev Dwivedi on behalf of Vidyalankar Institute of Technology. I welcome you all in this Java session. Uh, in this session, we are continuing with the multi-threading topic, and we are going to talk about synchronization in thread. Now, what is synchronization in thread and why do we need it? Now, in thread, there could be a problem with shared resource. Means if more than one threads are trying to access common resource at a time, then it could lead to a problem of race condition. Now, to understand that, let me take this very simple example. This is very simple. I have tried to keep it very simple just to make you understand this. Now, we have class A. Now, class A has nothing to do with the thread. We have class A that has a data member x equals to 0. And now, when f1 function will be called, x value is incremented, thread goes to sleep, and value of x is displayed. So basically, in f1 function, we have 3 steps. Increment the value of x, go to sleep for 500 milliseconds, and then display the value. This is it, correct? So every time f1 function is called, these 3 steps will occur. Now, this is my class B that extends thread. Now, what happened here is, in class B, actually, in run method, I intend to call f1 function of class A. In run method, up till now, we displayed for loop, right? For loop 10 time hello, 10 time hi. No, I mean, you can write anything you wish depending on your application. Now here in run method, I wish to call f1 function of class A. Now to call f1 function of class A, I need to have object of class A because f1 is a non-static function. So here object of class A is data member. So AOB, this is my data member. And I want to ensure that it is shared. So what we did is we created object of class A. Now we created 2 object of class B. Now class B is a class that extends thread class. So basically B1 and B2 are nothing but thread object. And to both the thread object, I shared a common object A1. So if common object A1 is shared, there will be only one copy of X available to both the threads through the common object A1. Now let's see what happens. B1 dot start. So B1 thread will go to runnable state, correct? And then B2 dot start. B2 goes to runnable state. B1 threads got processor allocation. Controls come here. Control is here, correct? Now this A1 is referred as AOB here because this A1 is passed here. Here it is A1, AB, so AOB. Now when B1 dot start is invoked, B1 goes to runnable state. When B2 start is invoked, it goes to runnable state. When it gets, suppose B1 gets processor allocation. So run method is called for object B1. Run method, F1 method is called for object. Run method is called for B1. Now B1, for B1, F1 is called using object. F1 is called using same A1 object. Huh? This AOB is nothing but A1 here. See. Control comes here. X value is incremented. X value now become 1. Now, before it displays the value of X, it goes to sleep. Like B1 thread goes to sleep. In the meantime, B2 would have got the processor control. B2 के लिए run call हुआ रहेगा और B2 के लिए A1 ने वापस F1 को call किया. B1, see here, for B1, F1 is called by same object A1. X is incremented 1. Now, it goes to sleep before it displays the value of X. So no value of X is displayed up till now. A1 goes to sleep. B1 goes to sleep. Now B2 dot start is invoked. It is in runnable state. Run is invoked. Again, F1 is called using same object A1. Again, X is incremented. X is 2 now. And B2 thread goes to sleep. Now what will happen is B1 will re-enter the runnable state and will try to display the value of X, but the value of X now B1 sees is 2. Now B1 will display the value of X, will go into dead state. B2 after sleep will see the value of X, which is 2. So the value displayed here is 2 and 2. Now why happened so? See, ideally what was the output? B1 के लिए start call होगा. B1 के लिए F1 call होगा. Value of X is incremented. It becomes 1. Okay, it goes to sleep. It should rise from the sleep. It should display value of 1. x is equal to 1, then b2 के लिए f1, b2 के लिए run, and b2 के लिए f1. So ideally output should be x equals to 1 and x equals to 2. But doesn't happen so. Why? Because one thread B1 was in middle of multi-step operation. Now why I'm saying multi-step operation? Because incrementing, sleeping, and then displaying. It was 3-step operation. My B1 is in second step. So it has not finished the third step in the meantime. So one thread was in middle of multi-step operation. Other thread comes and changes the value on which first thread depends on. So in the meantime, B2 comes, this changes the value of x to 2, and then B2 goes to sleep. So when B1 rises from the sleep, what it sees the value of x as 2 and not 1. So the intended output was x equal to 1 and x equal to 2, but the output that we will see will be x equal to 2, x equal to 2. This is race condition. Because one thread B1 is in race to finish all its operation before it is interrupted by another thread B2. Now we want to solve this problem. How we can solve this? We can solve this. See, ideally what we want? Ideally want the access should be synchronized. Now what do you mean by synchronized? Synchronized means if there are more than one thread trying to access the common resource, then if one thread has got the access, then there should be lock. Then there should be a lock. See, what we have is synchronization. See, now consider this example. See, everything is same. The only thing is F1 function is now declared as synchronized. F1 function is now declared as synchronized. Everything else remains same. We call it as synchronized method. Now what happens so is when b1.start is called, control is in, then it goes to ready, runnable state. Processor control is allocated. It calls F1 function x value is incremented to 1. It goes to sleep. Now it goes to sleep, barabar hai, but it is synchronized. So when b2.start, b2 tries to invoke run method and then F1, then b2 will not be given access to F1. It will be asked to wait because B1 thread has not released the lock over the resource F1. So once we declare it as synchronized, we will ensure there is access only of one thread at a time. So if B1 thread gains the control over F1, unless and until it locks the F1, unless and until B1 releases this, the control will not be relinquished. So now after 500 millisecond, B1 rises, it displays value of x as 1, and then dead state, and then B2 run method, B2 के लिए F1 call होगा, it increases the value of x to 2, goes to sleep, it arises and displays value of x as 2. So we get display as x equal to 1, x equals to 2. See, even though my first thread was not able to complete the operation before it went to sleep, because for first thread x was 1, then it goes to sleep. In the meantime, other thread tries to access, which was allowed in earlier case when F1 was not synchronized. But in this case, it won't be allowed because F1 is synchronized. So now this will ensure that there is a sequence of access unless and until one thread relinquishes all the control or the lock over the resource, other thread will not be able to access it or gain control over it. We call this as synchronized method. So what we did is the shared method is declared as synchronized. So it means that we can access this, we can call this method one thread at a time. Now suppose, see, it was very easy for us to just declare this method as synchronized. Now suppose this class and this method belongs to some other package and I have imported it. Suppose this is the scene. I have imported A. Some of this belongs to package P1. And I have imported it p1.a, and suppose this is public. Now it's like this. There are many classes from the package that we import, like scanner class, buffer data class, but can we go and make changes there? No. Now suppose there is some restriction. The restriction goes like this. It says that you can now see, and it is not synchronized. The restriction is now the class A object that you are accessing, class A belongs to some different package. You can use it. You can create the object, call the function F1, but you cannot go and make changes in F1. So now here there is a limitation that I cannot go and declare F1 as synchronized. So now I'll go back to state 0, means I'll get output as x equal to 2 and y equal to 2. Now we can overcome this. Here what we used was synchronized method. Now if the method cannot be declared as synchronized due to some reason, then we can make use of synchronized block. See here F1 is not synchronized. So this call to F1 is synchronized. So we call it as synchronized block. So call to F1 is enclosed within a synchronized block declared with keyword synchronized. Now everything else is same. Only the call to the synchronized method. So when we will use synchronized block, when we cannot declare the method as synchronized, the output in both the case remains the same. People tends to prefer that synchronized method, but this is only possible when you have access to it. Correct. Otherwise, if you are trying to share a method which you cannot go and declare at synchronized, then you have to use synchronized block. So if method cannot be synchronized, call to the method can be synchronized, and call can be synchronized using synchronized block. So let us see synchronization. Synchronization in Java is the capability to control the access of multiple threads to the shared resource. When we have 2 or more threads in a program, there may be situation that multiple threads tries to access the same resource at a time, and this will result into undesirable effect. And there is a need to synchronization. The action of multiple thread, we should ensure that only one thread can access the resource at a time. This is what synchronization is all about. Only one thread should be able to allow or to access the resource at a time. Now with synchronization, we can prevent data corruption, thread interference. One thread should not interfere the working of another thread, and there should be consistency. Correct? So this is what we desire out of synchronization. Now, there are 2 ways to do it. Synchronized method. If you declare any method as synchronized, the particular object can be locked so that shared resource cannot be accessed by other object. Once the execution of method is completed, then shared resource can be unlocked. So in our case, unless and until B1 releases the lock on F1, because F1 was declared as synchronized, it won't be given access by B2. And what is synchronized block? If it is used, if you want to synchronize some part of the method instead of synchronizing the whole method, or it can also be used in a case where you cannot go and declare the method as synchronized. So this was when we declare the method. This was like when we declare the method as synchronized, and this is here when we have a block as synchronized. So this is about thread synchronization. So here we finish multi-threading. There are many more interesting topics, and for details of these topics also you can refer Java to Complete Reference by Herbert Schill. Thank you very much. Happy learning.